Great, Karin, you can go ahead.
Good evening, everyone. Thank you so much for joining our STEM Sparks talk.
This girl has 1,000.
Oh, okay. Sorry, I heard some echoing there. I'm Karin Lebeau. I am the middle school director for the middle school fair. I've been doing this for quite a few years. And we're so happy that we have Cameron and Ariana here with us tonight. So thank you to Cam and Ariana for joining us and for everyone here who is joining us. I would like to introduce Cameron Dunn, who is a sophomore at Boston College High School. And I have to say, I'm incredibly impressed with Cam and his project, and I can't wait for you all to hear about his project and his path to the science fair. All right, here you go, Cam.
Yeah, so the whole science fair project really began with an issue, and that was how do I dispose of electronics? So do I throw it in the trash? Do I go to the Department of Public Works, which is what you're supposed to do? And really early on, I didn't know that you were supposed to go to the Department of Public Works to dispose of your old electronics. And this really opened up a whole range of different issues, especially with the metals that are used in electronics. And in this experiment, I really tried to investigate the effects that copper had on the nervous system. And I used the leech as a model for this. And I explored this in 5 different ways. So the first was a mortality study, and that's really just how much copper could the leeches take to survive? Would they die at a certain level? Then I did 2 studies that looked at their behavior. So whether the copper impacted how they ate, and then I also did how well they moved and whether they could seek darkness, which is how they escape predators. Then I also did something called a histopathology study. And that's just really a complicated word for looking at the leech under the microscope. So really seeing the effects with your eyes that the copper has on that leech. And then I also did something called proteomics. And that's a relatively new field. And it deals with the proteins. So those proteins can really show the effects in different areas. So the effects that I was seeing with histopathology, those were really seen and manifested in that proteomics work. And in all 5 different dimensions of this project, I really saw that the copper had a huge effect on the leeches and especially their functioning overall.
Great. So Cameron, we just wanted to ask you some more questions too about your experience in doing the science fair this year. How did you get started and why did you choose to do a science fair project? Like you talked about the spark of the idea, but sort of why did you decide to kind of go forward and explore science fair?
I mean, I have some really amazing people that I worked on this project with. So I had someone from UMass Boston, and then I also had someone from Beth Israel helping me. And that professor that I was working with at UMass Boston, he really helped guide me through some of the different parts of this project. And he was really the one that recommended I, first of all, put it in a journal. And then he thought maybe a future step could be going to the science fair. And early on, I wasn't really expecting to do that. I was just doing this project that I really wanted to understand it. I thought it was a pretty cool topic. But then when he talked about the science fair, it was just a really great way to show my research. And I thought, that's really what I want to do. And my mom had participated in the science fair many years ago. So I just thought it was a really good way to show my work.
That's great. So what do you feel like you got out of it, working on the science fair as opposed to just doing the project separate? What kind of skills and experiences?
Like, I think I really got to feel more comfortable presenting my research. I was really nervous going up to it, but the judges were actually really amazing. They were very conversational. And it just create a really great experience for science. And I really hope that everybody on this Zoom call, if you're in middle school, I really hope that you do pursue MSEF because it is such a great experience. It really develops your passion for science overall.
Great. So I think one question I had for you too is how does this fit sort of your long-term goals and what you might want to do? Like think about the next couple of years for you in terms of participating in science fair, but then sort of where you see yourself going beyond that.
Yeah, it's interesting because I feel like this almost matured my process of doing of sort of pursuing science, because the science fair really helped me understand that this is just the first step in what I want to do. I would like to expand this research, maybe go into other, like expand upon it by going into different organs, like their reproduction. But it just really, and then also I really want to look at this broader topic of electronic waste, but then also the environmental justice part of it. So just the steps that it brings after the science fair, really, it's amazing how it opens up so many opportunities and shows you how far you can expand with one little tiny idea from the beginning.
Cool. And then for the specifics of your project, I think, you mentioned all the different components that you looked at in leaches. And I think as we think about a science project or an engineering project, there's all these different components. So like with the science research, you have to have all the controls and the variables, and you had all of these steps. How did you think through that process and then also really work on your record keeping and keeping all your data straight and things like that?
Yeah, so the record keeping, that bit was really just being conscious of the long-term goal, especially with the science fair. So that was just putting everything down in my notebook. And it really came out to be this amazing piece of my work. It was almost a book in itself. What was the first part of the question?
Sort of how you thought through the variables and the controls and making sure that you were organized and knew what to focus on and what the different components were.
Yeah, so that was really with the help with that professor. That was also just like diligence by myself. But I think it's really important to have someone who knows what they're doing, so that you can have your own independent research, but there's also that person who's sort of guiding you that really knows science as well.
Great. Awesome. And there are, feel free to put questions in the chat. We're going to switch over and talk to Ariana right now, but then there'll be an opportunity to ask questions amongst ourselves. So you can feel free to add questions as they come up. So thank you, Cameron. So Ariana Spawn was a student in Littleton Middle School and part of the program there. And so we're excited to learn about her and her enthusiasm to speak to students about her experience and her path since. So welcome, Ariana. Do you want to just give an introduction of yourself and what you're up to?
Sure, yeah. So I know we were connected through Valerie Finnerty, who's at Littleton Middle School right now. I actually am from Chelmsford, Massachusetts, just a couple towns over, and got introduced to the science fair. I was a student at a Montessori school in Littleton at the time and got introduced to the science fair program. I think my first project was in my first year of middle school, which of course was 6th grade. And, I think I had a predisposition to being interested in science, from a young age. I was always kind of interested in nature and kind of how the world worked. And so I think I was a natural fit for the science fair, program, but was really fortunate in that I had teachers and parents and, a lot of folks that were really kind of supportive of those interests. And so I know that, want to acknowledge how helpful that was. So my, the projects that I did sort of took an evolution, as I was participating in them over the years. The first project that I did when I was in my first year of the program was kind of a little bit more like engineering focused. I built popsicle stick bridges, different kind of, using different structures. We did a kind of arch style bridge and a truss and a couple different, basic kind of bridge architectures, and then actually kind of rigged up like a weight. I think we used quarters. I don't remember exactly what I used to sort of test the strength, the supporting strength of these different bridges. And then it was really fun. Like the popsicle sticks would like splinter and crumble. And it was like, I was keeping track of basically how much weight each bridge could support. So that was cool, pretty engineering focused. I didn't ultimately decide to go into engineering, but it was cool to try that out, much to my father's chagrin, who was an engineer. And then the second year I did, I was starting to kind of explore my interest in the environment a little bit more. And I did a project that actually tested, we had been spending, every summer we would go to the beach, and I was noticing there were, I'm sure you guys have all seen this at the beach in, Massachusetts, there are certain beaches that have sort of these structures in the water called breakwaters. Sometimes you'll see fencing up against some of the houses that are on the beach. And I was kind of starting to wonder, like, are these are to protect the, the houses, the shoreline from erosion, from waves, from hurricanes, from sea level rise. And I was, kind of looking at these wondering, like, do these work? Like, is this really like going to save these houses from falling into the ocean? And so I came up with this kind of fun little, again, my engineering father helped me devise this, like, we called it a wave tank, basically. It was basically just like this box that we actually brought sand in and kind of recreated sand dunes in it, and developed like a little mechanism to basically send waves down to it. And we tried out a breakwater, and we tried out some rocks, like mimicking kind of like a sort of boulder fence. We tried a little, I think, popsicle stick fence came back in. So tested out those different mechanisms. And then by my last year, I was pretty much fully interested in kind of environmental issues. And I tested out sort of different substrates. I was testing what substrates would protect pollution from going into groundwater. So I had kind of like a little water reservoir, again, in a tank, and I would drop, I don't remember what I used, some sort of, hydrogen peroxide or some sort of acid that would show up on a pH test, a pH strip, and tested which kind of substrates were better at holding that chemical versus what was percolating down into the water underneath. And so all that is to say, I'm now working, I'm a federal policy advisor for a senator, for a United States senator, and I work on environmental policy every day. And I use kind of the science and the sort of skills that I first started developing when I was in middle school, doing these science projects, to kind of ask questions and think critically about issues in my work every day. And I can certainly talk about more about kind of the path from middle school to where I am now. But I think I'll just say, science is just such an incredibly useful lens to think about things, to look at the world, and it fosters curiosity and kind of a desire to learn more. And that is just such an important, I think, skill that will serve you guys kind of all through the rest of your education. And once you get out into the working world, it's definitely still serving me today. So it's very exciting to get to talk to you all and get some excitement going about these science projects.
Great. I definitely want to talk to both of you about, again, how you get your ideas, excuse me, how you get your ideas and sort of how you piece these pieces together, because you both sort of touched on that. But I'd love to hear a little bit more, Ariana, too, about your work. And again, as you said, sort of where you ended up and how you still use sort of the science processes and science thinking in your work. So if
Sure, yeah. So I guess I'll just really quickly kind of run through, I mentioned that I was sort of, my interests were evolving when I was, in middle school. Obviously I continued to kind of, be interested in this stuff through high school. And then, once I got to college, I really kind of had a chance to explore this stuff more. And I studied biology in college, and, moved on by the end of my 4 years in college, had kind of pivoted from a straight biology focus to more of a conservation biology, ecology focus. I did some research projects in college that like absolutely were just kind of fancier versions of the stuff that I did in middle school. But then pivoted, you know, as I was coming out of college, kind of starting to work at this, what I call the science policy interface, which is a thing, will always be a thing because there's so much, you know, the role of kind of science in informing how we make decisions as a society, especially when it comes to environmental issues, is just so important. And so I was able to kind of use, you know, again, those kind of skills of thinking holistically about a problem, understanding all of the different variables that could be kind of influencing something that you're seeing in the environment or something that you're seeing kind of out in the world, you know, figuring out the variables, figuring out what's going on. And then, you know, you have to know what's going on, what's causing kind of the problem or what's creating the situation that you're seeing in order to know what the solution is, you know, to figure out kind of what the right decision is to make about, you know, making a certain management decision about how we're managing, you know, a forest or our oceans or whatever, you know, whatever that example is. And I think those kind of principles of asking questions, you know, trying to understand the whole situation absolutely apply to kind of policy problems that I deal with now, just as they apply to science problems when you're asking yourself a question, you know, in the context of a science project or what do you have. And I think, you know, the other thing I'll say is that over the course of kind of my career and where I am now, you know, you also learn about the limitations of science, right? What science can and can't do. Science cannot always tell me what the right sort of policy decision is when it comes to something like managing our environment or managing our natural resources. But what it can do, right, is it can help you understand the world you're living in. It helps you understand the problems you're seeing. It helps you understand kind of what's happening around you. And only kind of through having a thorough understanding like that can you make an informed decision, for example, in my line of work about, you know, what the right kind of policy or management choice is for a particular environmental issue or problem. And so it's been really, really critical, I would say, to kind of my path and how I ended up where I am today.
Well, I think what's so important too is for middle, you know, especially with middle school projects, also with high school projects, but you're learning so much about how to think about different components, what's required to think critically and puzzle something out. So you don't just take something at face value and you really think about pieces so that when you are presented with issues in high school and college and your career, you have those skills, right? So that you can think through all the systems of what's involved, because very few things are really black and white.
Exactly. It teaches you how to ask questions and how to kind of, you know, take stock of a kind of big or complicated question or problem. Definitely.
So going back, kind of jumping off on that, asking questions and how do you get started, you know, to both of you, you know, Cameron, you talked about how sort of your spark was this idea of what do you do with your e-waste, and that there was a question there. And Ariana, you talked about being at the beach and noticing something and having questions. So what sort of advice do you have for students who want to come up with a great question that they can dig into for an engineering challenge or a science research challenge? Like, what would be your advice on getting started? But you both.
Cameron, do you want to go first?
Sure. I think that the best advice that I got from people close to me was that it really takes a small passion, a small idea, and it has to be a passion that you really are motivated to do a whole project on. E-waste and like the beaches, it's really important to be really interested in that topic so that you can have that motivation to and continue to pursue that interest throughout the project. I'm really interested in electronics and what the future holds with so many electronics, and especially the environmental impact of that. And that's really what really got me through this entire project and allowed me to continue to research and go into different fields to see these problems on many different levels.
That's great.
I think that's exactly right. I mean, I would just add, I think what is most helpful is just, you know, being curious, right? Like observing kind of what's going on around you, whether your interest is in something in biology or in physics or in environmental science, just kind of watching things happen around you and wondering like why is it the way it is? Why is it like that? I think is just kind of fostering that sort of curiosity and moving towards something that excites you and interests you, just like Cameron said. I think I'll really quickly share this story because I think it's maybe helpful. When I was in college, I was working on my senior thesis, which was in kind of the conservation biology field. And it was a pretty desk focused project. I was unfortunately not like out in the field, like collecting samples and like tracking wildlife or anything like that. It was very data analysis heavy project, which side note, I hated. But I didn't know that at the time, right? That was my first time doing a project like that. And I'm certainly glad I did it. But I think my thesis advisor, who was, a conservation biologist, sensed my kind of frustration. Like I wasn't really making much progress on the data analysis. And I think, I was kind of dragging my feet on it, honestly. And he, at one point, he just gave me this advice and he was like, you know what, like take the weekend off and just like go outside and sit under a tree and like watch some birds, like observe the birds, see how they're behaving, like notice what they're doing. And like, ask yourself, like, why do you think they're doing that? Why are they doing this behavior? Why are they acting like this? And at the time I kind of was like dismissive of that and was like, I don't want to go out and like watch birds. But in retrospect, right, he was like trying to bring me back to that kind of initial curiosity and just like wondering like, why does the world work the way it does? Like, why is a bird, doing this weird thing in a tree branch, for 20 minutes right now? Just kind of asking those questions, I think. And always reminding yourself that like maybe what you're working on in that particular moment isn't thrilling to you, but like taking a step back and thinking about the bigger picture and kind of the broader context of what you're working toward. That's the cool thing about science is like no matter how big or little your project is, you're contributing to some body of knowledge. You're building your kind of own understanding. And so I think that's what's so cool about it.
Yeah, and I love that in both of your stories too, like you started, like Cameron, for your project was environmental sciences project, but your passion, what you started with was electronics. And, Ariana, some of the projects you mentioned, they were engineering projects, but they were focused on sort of this environmental concept. So again, there's what's so cool about science fair and where that opportunity is it is about understanding your world. So you might have a content that's inspired by something, but the kind of the mechanism or the way you address it is a related field of science because there's so much overlap. So I want to give you both a chance to ask questions of each other. There was also a question in the chat to Cameron about how the professor knew about your research and sort of how you made that connection as well. So.
Sure. And I want to make sure Helen just put a really, I think, good question in the chat that I want to make sure we get to. I don't know if we're going to have questions at the end.
Sure.
Okay.
Yeah.
One question I had for you, Ariana, was like, what are you working on at the moment for the environmental issues, that you're working on?
Yeah. Well, that was a appropriate slip up because I do work a lot on environmental justice issues right now for my boss. Just because it's a big focus and a big passion for him. But my portfolio working on federal policy is huge. I mean, I cover everything kind of under the environment, energy, natural resources portfolio. So that includes, public lands management, wildlife, ocean and coastal issues, climate and energy, which is obviously an incredibly huge and incredibly pressing priority for us right now. And then the environmental justice portfolio, which, is pretty interdisciplinary and obviously crosses over quite a bit into the kind of the policy and the social justice space. But, again, it's a lens through which, we look at these issues and think about these issues. And so, there's a lot, I could spend a lot of time talking about all the kind of different sort of areas I'm focusing on right now, but I will, just because of the context of your project, I'll just briefly mention that, this idea of electronics recycling and kind of recovering materials out of these electronics is a huge topic right now because of our push toward decarbonization, toward moving off of fossil fuels in order to combat the climate crisis. It's creating a little bit of challenge because we need new materials and new minerals to, for example, build out all of the electric vehicle batteries that we need to build out in order to electrify the transportation sector. And those minerals have to come from somewhere, and mining them has some sort of environmental impact. And so, and I actually had a meeting today about this. We need to figure out a system to recover and to recycle those batteries when they come to the end of their life. And understanding how to do that with minimal kind of environmental impact in its own right, and how to do that in a way that is economical, is a huge, like, pressing issue. And so I think that's a great example of, like, you know, should you choose to go down this path and become, you know, work on environmental science or policy, like, you could very well find yourself working on the same issue that you, you know, did your project on this year.
Mm. Also, like, how do you manage such a diverse range of different issues regarding the environment?
It's a good question. I mean, it's a lot to keep track of. I mean, I'm really lucky. Obviously, I'm part of a team, and I have other colleagues that, you know, kind of can pick up certain pieces of the portfolio for me. We actually have a fellow in our office right now, which is actually the same fellowship that I did a couple of years ago coming out of grad school, that puts you, it's meant for folks coming out of science graduate degrees, and it places them either in a federal government agency or in a congressional office to do policy for a year. So we have a fellow who's helping me with this portfolio. We also have this really cool resource called the Congressional Research Service, which is sort of like an independent, unbiased, kind of independent third-party organization that really kind of functions like almost like our science librarians or our policy librarians. Like, we can go to them and ask questions, and they're incredibly knowledgeable. And then, like, we rely a lot on the expertise of outside groups and outside experts that are working on these issues, which of course is a whole nother conversation, because you have to learn how to, you know, who to listen to and who's pushing an agenda, right? But yeah, it's a team effort for sure.
Great. Let's transition over. So there's two questions about finding professors for your research, and then also if it's intimidating to work with professors, and if you can share a little bit of that process for students who might not have access to those resources. And I have some ideas there too.
Yeah, so my relationships with these people were really built from scratch. I didn't know them at all from the beginning. I was a high school student in the middle of COVID, so who would really want to work with me? I was pretty much the last person that a professor would really want to take in. But I emailed many proteomics labs, especially, and histopathology labs as well. And I was really fortunate to get they were actually the only responses I got. One from UMass Boston, and then one from Beth Israel. And it's pretty amazing, because the people that get back to you are really the people that want to work with you. So I wouldn't say it's intimidating. Those people, at least, weren't intimidating at all, because they were the people that really went out of their way to help me. They really wanted to get my project. They really wanted to help me through and guide me through the project and really develop my understanding of these fields, but also develop a project that's really cohesive and really applies to our current times.
Great. Yeah, I think too, one thing too, as Ariana, as you were talking about the electronics recycling too, is I think when we think about potential experts or sources of information, you know, outside of professors and formal labs, there's a lot of organizations that are dealing with waste. And what are some of those sort of trade groups or professional groups that could also be sources of information, if not like a mentorship relationship, again, some sort of outreach. So then Ariana, do you use the science fair process or sort of that way of thinking to process your own work now, in terms of thinking about the ideas, coming up with a sort of a plan of how you'll address them?
Sure, I absolutely, right? I mean, I'm not, you know, at a lab bench doing science anymore, but I absolutely, you know, when a stakeholder or a constituent comes to me and says, there's this problem that I want to put on your radar, you know, we want to do a bill, or we need you to, you know, send a letter to an agency on this, or, you know, whatever the kind of issue is. You know, I just going back to kind of this question of like, right, where do you find experts, and kind of like, you know, we're all, you know, we can't be expected to know everything, right? We have to go to experts to ask questions. And so it's figuring out, you know, taking this new issue that maybe is something that I had never even thought about before, never worked on before. And I'm really starting from ground zero of like, where do I need to go to get the information to figure out what the right kind of course of action is here. And so it's asking those same questions. You know, just like Cameron had this question of like, what do I need to do? Who do I need to talk to? What do I need to think about in order to figure out like how to deal with this problem of extracting the copper from this electronic? It's really, it's kind of just practice knowing where to turn for help. And I think you realize that there, you know, especially when you're a student, there are just so many people out there that I think are eager to work with students and want to help you learn. And so, you know, kind of like Cameron said, like, don't be afraid to send those emails. And if they don't want to work with you, they won't write you back. If they don't want to help me with my policy question, they won't write me back. But, you know, never be afraid to kind of do that outreach and just ask for help.
Great. Great. Are there any other questions either for each other or in the chat? I think too, Ariana, I really appreciated in your story about the data analysis piece too, and recognizing what you didn't want to do. And again, having the opportunities in middle school and high school to experiment with different types of research, types of work. It gives you that experience so you know what you like and what you don't like.
Absolutely.
In a way outside of what we traditionally experience. So
absolutely. And I want to underscore that I was in college. I mean, I'm still figuring that out for myself right now, but you don't have to have all the answers in middle school, right? Like I was obviously still in my senior year of college, trying things out, finding out they weren't for me. It's a lifelong process.
Absolutely. So another question about, do you feel like it's a necessity to work with a professor in the science fair?
No, I wouldn't say at all. I might have come off during this time that the professor helped me a lot, but I really think that you can do an amazing project just by yourself. I mean, Ariana did a pretty amazing one herself, and she did that independently. So I think that no, it really isn't important that you work with a professor on this. It just helped me in this case, but you can really develop an amazing project yourself.
And I'll just add, I mean, it can absolutely be daunting trying to figure out a project, right? And so I didn't work with a professor, but I did, I was fortunate enough to have a father that was kind of had a little bit of a science background and was there to kind of bounce ideas off me and help me kind of flesh an idea out. And so whether it's a parent, a sibling, a friend, your science teacher, I mean, like, just think about kind of who you have in your life that might be willing to sit down and brainstorm ideas with you. And I think certainly doesn't have to be a professor, but having help, like I said, is obviously always a good thing.
I think that an important thing that you said there, Ariana, was like the science teacher piece. I mean, the science teachers are always the people that will want to work with you. They work with kids every day, and they're the people that really have a passion for science. So I think that even approaching your science teacher about a project idea you have is really important, because they know they've studied science for so many years, and they really know how to develop a project themselves.
Great. Well, I think we should wrap up on that note. I think that, one of the things to emphasize on that point is, science doesn't happen in a vacuum, or at least most sciences don't happen in a vacuum. And you want to be collaborative. You want to find those people that you can work with. And so I think as we get into the end of the school year and look ahead to summer months and think about next year, thinking about this summer for students, what do you want to read? What do you want to watch? What do you want to research, so that you can get a jump on next year and think through what you're passionate about, where there's possibility, where there's great research that you can base the project on. Keep an eye on MSEF's resources. We'll be sharing lots of ideas and speakers and sessions and things like that. So follow along. And we are really excited, and congratulations to all the middle school students who are participating in projects, and the judging sessions are going on this week. And then the award ceremony for middle school will be on Tuesday night. So thank you to everyone.
Thanks all.
Thank you.
Thank you.